Welcome to Study Loop.
Hello everyone, today we're doing chapter 17, problem 2, and this problem asks us that what orbitals are involved in the bonds that are indicated on blue in these following structures that are shown here. What orbitals are used in the bonding to create these bonds indicated in blue? And of these bonds indicated in blue, the carbon-carbon bonds, which one of these are the shortest? So in order to determine the hybridization of each carbon atom that's corresponding to a bond, or the two atoms that create one bond. So for example, here we have carbon-carbon, carbon-carbon, but here we have a carbon-hydrogen bond. And on the right molecule, we have carbon-carbon, carbon-carbon. So each bond is composed of two molecules, two atoms, sorry. And how do we know the hybridization of these two molecules or two atoms? So we know that the max hybridization for a carbon can be sp3. And why is that sp3? Well, let's see, we have a carbon in the middle. We know that in order to be neutral and satisfy the octet rule, carbon has to have 4 bonds to it. So having 4 bonds to it means that it has 4 different groups attached to the central carbon atom. And if you look at sp3, well, s is to the power of 1. Excuse me. S is to the power of 1. P is to the power of 3. So 1 plus 3 equals 4 things attached to it. So you can imagine now if carbon only had 3 things attached to it. So let's say we have a carbon that will bond to an oxygen and had 2 more bonds going right and left. Well, this carbon still has 4 bonds, so the octet rule is still satisfied. But now, in essence, it has a substituent on the left, a substituent on the right, and one substituent on the top. This double bond counts as one thing. So in essence, it has 1, 2, 3 things attached to the central carbon atom. So this carbon will be s to the power of 1, p, but p to the power of what? Well, we need 3 things. S is to the power of 1, so 3 minus 1 equals 2, so it'll be p2. So this carbon will be an sp2 carbon. But this carbon has 4 things attached to it that are not double bonds, 4 separate things. It would be an sp3. In this bottom case, even though we have 2 bonds to oxygen, these 2 bonds are bounded to the same atom. So they're considered as one substituent, the same thing. So that's why we have only 3 different groups on this carbon. That's why this would be an sp2, and this would be sp3. So using that logic, let's determine this bond here. So we know the carbon on the left has 2 hydrogens, carbon on the right has 1 hydrogen, and we know this because we have to satisfy the octet rule. So this central carbon, as it was drawn before, had only 2 bonds shown to it. But we know that because it's neutral, it has no positive or negative sign attached to it. So we know that it has to be having 4 bonds, has to satisfy the octet rule. So we have to add 2 hydrogens, so it makes that 4 bonds. So now we see that this carbon has 1 group, which is 1 hydrogen, 2 group, which is the second hydrogen, and a 3rd group, well, it's this double bond here that's bounded to this other carbon. So in essence, we have 1, 2, 3 things attached to this carbon. So we have an s to the power of 1, and how many p? Well, we need p2. So 1 plus 2 equals 3. These 3 things are attached to the central carbon atom. And now what about this carbon atom on the left? Well, this carbon atom is bound to 1 thing here, 1 hydrogen, and 1 group on the left. So this carbon atom also has 3 things attached to it. So it's also an sp2 carbon. But now we have a double bond. We have a second bond here. It's not just a sigma bond. A single bond is formed by a sigma bond, but the second bond is what we call a pi bond. So pi bonds, they're created by p orbitals. So this sp2 is a creation of the single sigma bond. But then we have to have a creation of this pi bond here, the second bond. And that is formed by p orbitals. So remember, pi bonds are formed by p orbitals. So we have a pp bond here as well. Well, now what about the bond here? So on the left, or sorry, on the right, we have this carbon that has 1 group on the bottom, 2 hydrogens, and 1 group on the left. So that's 4 separate things bound to this carbon. So this carbon on the right will be an sp3. S to the power 1, 1 plus 3 equals 4 different things attached to the central carbon. Now what about the carbon on the left? Well, this carbon on the left is bound to the sigma bond here, is bound to this pi bond here, and bound to another sigma bond on the bottom. So we have 1, 2, 3 groups attached to the central carbon atom. So this would be an sp2. 2. 1 plus 2 equals 3. Here it has just a single bond, so we don't have to do or add any pi bonds or p orbitals. So this will be the full notation of this bond. So next we have this bond here. So we see that this carbon atom on the right has one group on the top, one group which is bound to hydrogen, and one group on the bottom. So it also has three things. So this would be an sp2 carbon. But now what about hydrogen? Well, hydrogen is only bounded to this one carbon. Hydrogen does not have anything else bounded to it. So this would just be an s orbital, one thing. Now, the question asks which one of these bonds would be the shortest in length. So what we know is that the greater amount of s characteristics, the stronger your bond is going to be. And the stronger your bond is going to be, the shorter in length is going to be as well. But what else we know is that double bonds are going to be stronger and shorter than a single bond. So right away, we're comparing a double bond versus two single bonds. So right away, we know that a double bond is going to be stronger and shorter than any of these single bonds. So we know that this pp orbital is going to be the shortest orbital, or shortest bond. Now, what about this molecule on the right? So on the right, we have a carbon on top, carbon on bottom to make this bond right here in the middle. And a carbon on top is bound to a group on the left, group on the right, and a group on the bottom. So it's bound to three things. So this would be sp2. And a carbon on the bottom is bound to those same three things, a group on the left, group on the right, and a group on the top. So it would also be sp2. Remember, s to the power 1, 1 plus 2 equals those three things. Now what about this carbon? Well, this carbon, as it's drawn, shows only 3 bonds. But remember, because it's neutral, we know that it has to have 4 bonds. So we need to draw in those hydrogens. So now that we drew in those hydrogens, we see that this carbon on the top is bound to 1 hydrogen, 1 group on the top, 1 group on the bottom. Those are also 3 things. So this also be an sp2. And this bottom carbon is also sp2. But remember, these sp2, the sp orbitals, are only for your sigma bonds, only for your single bonds. But here, this bond has a pi bond. So remember what we did before? Pi bonds are made by p orbitals, so we need to add that p orbital bonding to another p orbital from these two carbons. And remember, a double bond is going to be shorter than any single bond, so this bond will be the shortest bond in this molecule here.